Welcome back to a new machine learning tutorial. In this video, we are going to talk about random forest classifier. We are going to talk about the logic behind the algorithm. We are going to code it using Python scikit-learn. We are going to talk about its parameters and we are going to do hyperparameter tuning. Let's start coding. I'm in VS Code interface right now. I will be using that in this tutorial, but you can use any code editor that you want. I'll be closing the welcome page and I'm going to be creating something like random forest classifier, and it's going to be a Jupyter notebook. I will be talking on Jupyter notebooks in this tutorial, and now what I'm going to do is I'm going to add a title like random forest classifier, and let's talk about the concept. So I'm going to be both explaining and typing some important keywords that I think, and then we are going to talk about the math behind the random forest classifier. Then we are going to train a random forest classifier using Python. And I will talk about the parameters of the algorithm and how we can optimize them using hyperparameter tuning techniques. And then we are going to make predictions with the tuned machine learning model we create in this video. So a random forest classifier is an ensemble machine learning algorithm that combines the predictions of multiple decision trees to produce a more accurate and stable prediction. It works by constructing multiple decision trees during training and outputting the mode which is most frequent of the classes as the final prediction for classification tasks. The idea is that by averaging the results of many trees, the model reduces the risk of overfitting to the training data and improves generalization to unseen data. So let's talk about the concept and the math behind it. So I'm not going to give all the formulas in here. You can check that if you want from the scikit-learn documentation or any website in Google. I'm going to be talking about how it works behind. So instead of formula focused thing, we are going to understand its logic. So in the concept side, random forest is an ensemble technique, as we talked, that creates a forest of decision trees. It builds each tree using a different subset of the data. Like we have these subsets, it uses a different subset and a random subset of features. This randomness ensures that the trees are uncorrelated, which reduces variance and avoids overfitting. So, math behind it. Bootstrap sampling. Each tree is trained on a random subset of the training data. This is known as bootstrap sampling. So, second, random feature selection. At each split in a tree, only a random subset of the features is considered. This helps create a diverse tree. And the last one, voting. So, once all trees are trained, the random forest makes a prediction by taking the majority vote of the individual trees. Like let's say we have 5 trees, 3 predicted the class as X and 2 predicted the class as Y, so we take the X as the prediction. So now it's time for coding. So I will be going in a Python cell and I will do my imports firstly. I'm going to import ensemble video topic firstly, then I'm going to import make classification for creating this lecture's data. And then I will say from scikit-learn.module selection import train test split, and I will say from scikit-learn.metrics import accuracy score, which is going to be our evaluation metric in this video. So let's create our data. I will say X, Y, and we will use make classification. Number of samples, let's create a data with 1000 samples, and number of features, this is going to be X amount, I will say 20. And number of informative, I'm going to say 15. Then I'm going to say number of redundant as 5. And by default, let me quickly show you X and Y. By default, Y returns as binary classification problem, just like this. So we have this kind of vector in the Y side, binary classification problem, as the target is ones and zeros. And we have this type of matrix in the X side with 20 features. Okay, now we are going to use train test split for having our training and testing sets, and I'm going to summarize the concept quickly, but you can check my tutorial on train test split for learning more about the topic. I will say train test split x, y, and I'm going to set the test size as 0.2, and let's talk about it quickly. So we are going to train our model with the training set x-train and y-train, and x-train is going to be our training data, y-train is going to be our training data labels inside the training set, and then we are going to make predictions with our trained model using x-test, and we are going to compare the predictions with the actual y values, y-test. So this is how we can use train test split for model evaluation. And by setting this test size 0.2, we have 1000 samples, 800 data points are going to be in here, and 200 is going to be in here. So 80% in training, 20% in testing. Okay, let's initialize the random forest classifier. So I will say rf classifier, and we are going to train the base model firstly. Then I'm going to say random forest classifier dot fit x train and y train. We are training the model by this. So let's evaluate our results. We can make predictions with this model right now, like we can say predict x test, and we are going to have a new array like this. We have this vector, the predicted values, and now we are going to compare them with the y test we have. So for this we will say y predictions, and we will use random forest classifier.predict x test, and now we can call accuracy score like y test and y predictions, and our accuracy score is 0.87. So now it's time for hyperparameter tuning. Most of the machine learning models have parameters, and we can optimize them for getting better predictions. And hyperparameters in a random forest control the complexity and performance of the model. Tuning these parameters helps us optimize the model to get the best performance. Common hyperparameters include the number of trees, maximum depth of trees, minimum samples required to split, and the number of features to consider at each split. And now I'm going to be writing them and talking about them. So we have the number of estimators, so number of trees in the forest. This is, we can call it like number of trees in the forest, and max depth is going to be the maximum depth of the trees. Minimum sample split is going to be the minimum number of samples required to split an internal node. Minimum samples leaf is going to be the minimum number of samples required to be at a leaf node, and we have the maximum features. It is the number of features to consider when looking for the best split. And we are going to use grid search, which is for testing out all of the combinations of the parameters and then returning the best one. So we will say from scikit-learn.model selection import grid search cross-validation. Then we are going to define a parameter grid, like parameter grid. It's going to be number of estimators, and we can give it a list like 50, 100, 200, 300. You can extend this list, it's completely up to you. More values you try in this side, the better chance to get a better model, but also it means more computational cost. Also, since we are giving this kind of parameters and not giving a big list, maybe our base model can outperform the parameter tuned version. So if you want to improve the performance, you can extend this list and find the better model. So we will say max depth, and I'm going to say none, 10, 20, 30. I don't want to give a big list in here. Minimum sample split, let's give 2, 5, 10, and I will say minimum samples leaf, I will give 1, 2, 4, and maximum features I will give auto and square root. So again, you can extend this list, and I'm going to tell you a method like you train your model, you get the best performing parameters, and for the minimum samples leaf you have 4, let's say. You can extend this list in the fourth way, like you can add 5, 3, 6, 7 and try to find a better model. So I'm going to set this dictionary, and then I will say random forest classifier is going to be, again, I'm going to initialize it like this, and now I will set the grid search like grid search is going to be grid search cross validation estimator is going to be random forest classifier, and parameter grid is going to be the parameter grid we have, and I'm going to set the cross validation as 5. So this means that we are going to split our data into 5 folds and try them one by one. I have a tutorial on cross validation. You can check the tutorial for learning about it more. And now what I'm going to do is I'm going to set this, then I'm going to say grid search dot fit x train and y train. So I will be training my models. When this finishes, I will be re-recording. It can take some time. I don't want to take a lot of time from you in this tutorial. I'm going to be re-recording when this finishes. So it finished in 2 minutes and we have it in here. Now let's see the best parameters selected. So grid search, best parameters, and our best parameters are 20 for the max step, square root for the maximum features, 1 for the minimum samples leaf, 2 for the minimum sample split, and 300 for the number of estimators. Again, you can extend this list. Let's say you find 300 in the number of estimators. You can try it with 400, 500, 250, completely up to you. And now what we are going to do is I'm going to save the best estimator, like best random forest classifier is going to be grid search dot best estimator, and now I can use the features, like I can use feature importances, I can use, let's say, predict method. I'm going to be retyping that predict, and we can make predictions like let's pass the x test, and we are going to save this array to like ypred tuned is going to be this array, and now I will say accuracy score y test with y predictions tuned, and let's see our result. It's 0.89. Okay, let's compare it to base model we trained in here. It was 0.87.5. Now it is 0.89. So we improved the performance using hyperparameter tuning. So here are our better performing parameters, and let's summarize what we did in this video quickly. So we start by talking about the random forest classifier and the concept like this, and then we talk the math behind that, and we import the random forest classifier, make classification for data creation, train test split for evaluating the models, and accuracy score for the evaluation of the results. We create our data with 20 features and 15 are informative. We did train test split, we trained the base model, and we saw how we can do predictions with the model we trained, and we make predictions with the machine learning model and store them in by predictions. Then we get the accuracy score on that. Next, we talk about the parameters it can take, and we define the grid for the parameters. Again, you can extend this list, and we trained our model using grid search. We tried all the combinations behind that. Since we are using grid search, let's say if you use random search, I have a tutorial on that on the channel, we can just try some of them instead of all, and we can give a bigger list, and then we fitted our model, we get the best parameters, then we set the best estimator and saw how we can use the methods like feature importance or prediction, and then we get the accuracy score on the tuned model. Let's get to the outro. Thanks for watching this video on random forest classifier. I have a playlist named machine learning tutorials where I have more than 40 videos, just like this one. You can reach to that playlist from the cards of this video or from the description. I'm sharing new data science videos every week on my channel. You can subscribe for more videos like this. Have a great day.